All right. So again, the idea is we set up the system of equation as an augmented matrix, put the answers here. We don't have to write the x, y. We draw a line to separate what was where the equal sign was, and we write all the coefficients on the left. And when you get a 0 in that bottom left-hand corner, that's called row echelon form. I don't know where the word echelon comes from, but that's what it's called. We could look it up. Now I'm curious. I hate when I ask questions because I get curious and then I can't help but wanting to know right away. Okay, Stephen's going to help me out. Why, where the word echelon comes from and why. And getting that 0 in that bottom form is called Gaussian elimination. So what we'll do is we'll create a matrix, an augmented matrix with the answer matrix and a line, and then the coefficient matrix. And then we're going to do elementary row operations. And the word elementary here is important because it is elementary math that we're going to be doing. We're going to be multiplying numbers less than 10 and adding might be numbers bigger than 10, but not a lot bigger than 10. Okay? And things that you're allowed to do. You're allowed to switch any two rows at any time. So you have your matrix, you can switch them. Because if you had two equations, it doesn't matter which is your first equation and which is your second, you can switch them around. You can multiply a row by any non-zero number. Multiplying by 0 is kind of pointless because then it makes it equal 0 and it just sort of goes away. And then you can add one row to the other. And that's the elimination thing you've done in the past. Say, for example, you had x plus 2y equals 3, and you had 3x plus 5y equals 7. If you wanted to solve this, well, I could multiply this first equation by a negative 3. What would that do? That would make this negative 3x minus 6y minus 9, right? If I multiplied that first equation by a negative 3. And then if I added these two together now, I would get 0x's, negative 6 plus 5, negative 9y, and negative 2. So y would equal 2. That's what we did when we used elimination. We're going to do the same thing now, only we don't have to bother writing the x's and the y's. So the hope is that it's a little bit quicker because you don't have to write your x and y's. And especially when you have three equations, you're always dealing with just one matrix at a time. Whereas the three equations, when you solved them as a system of equations, you had work all over the place and sometimes it got a little confusing. So hopefully this makes it a little bit more organized and easier to follow. Then once you got y equals 2, you could plug it in and figure out what x is. X is negative 1. And that is really, really lucky because I just quickly made that question up out of my head. The fact that we got no fractions as an answer is highly unlikely. I don't think I could do that again if I tried. Yeah, why is it echelon? Here it is.
Because it's a formation. It's a formation in which groups are arranged in parallel lines, either with each line extending to the right of one front, or with each line extending to the left of the one in front, so that the whole presents the appearance of steps.
All right, that makes total sense to me now. What?
Read it again.
Yeah, I better read that again.
Read number 3.
Number 3 is a formation of troops.
Yeah, well, that's the
So in parallel lines, either with each line extending to the right of the one in front of it, left, so that the whole represents appearance of steps. So that's where you would have like one row like this, then the next row like that. Is that what they're saying by steps? Or maybe, yeah. And what happens, I guess, if that's where it comes from, what happens in a matrix, if you had a big matrix, you would need I don't know. Maybe you would have this. As long as you have zeros here, that would create the idea of steps. That's a definition I will not remember. And when it comes up again, I will not be interested in figuring out where it comes from. But this would mean that 7, x, y, z. What's the letter in the alphabet after z? A. 7 a's would equal, oh, we need an augmented matrix. Okay, I'll erase this. It doesn't matter. Okay, here's our first question. We're going to solve this one with Gaussian elimination. The first thing we do is we set up our matrix with a line here, 10 and 16, 1 and negative 2, 1 and 4. And what we do for work is as follows. Our hope is to get this one in the bottom left to be a 0. Can you see if I take row 1 and subtract row 2, that would give me a 0 there? So for my work, I'm going to tell myself that I did row 1 and I subtracted row 2. Maybe I even say row 2 is now going to be equal to row 1 minus row 2. Row 1 stays the same, 1, negative 2, and 10. But when I do row 1 minus row 2, 1 minus 1 will be 0. Negative 2 minus 4 will be negative 6. And 10 minus 16 will be negative 6. Once I get a 0 there, I can say, so minus 6y equals minus 6 means y is equal to 1. Plug that back in, and you'll get.
Jared, what does that say?
5, 0. Yes.
So.
So.
Oh.
So.
Okay.
Not 5, 0. So. Minus 6y. That's good. Right? This is not a 2. You never know. And a quick check, does it work in both of them? 12 plus 4 is 16, yes. So once you're done these, you can always check them both to see if you're right. But we have reduced it to row echelon form. And that one was pretty simple because we could do it in one step. Again, write your augmented matrix. 2, negative 3, negative 2, 4, 1, 24. What would we have to do to row 2? To make this a 0. What would we have to do in total? You're allowed to multiply and divide, and then add and subtract rows. The only thing about dividing is you might go into fractions, right? Might make your life a little bit more difficult. Multiply the top one by 2 or negative 2. I like negative 2 because then I can add. Is that okay? If I multiply the top by negative 2 and then add it to row 2, well, this times negative 2, first of all, I'm not changing my row 1. This here, that little note there says I'm only changing my row 2. That's why it's good to write row 2 equals. So we know which row we're changing, and I'm only changing row 2, so my row 1 is going to stay the same as 2, negative 3, negative 2. My row 2 is now going to change. I'm going to take row 1 times it by negative 2. So I'm going to get negative 4 plus 4 will be 0. 6 plus 1 will be 7. And 4 plus 24 will be 28. And the idea behind this is being easier than what we used to do with elimination is there's less things you had to write out. And there's less times you had to stack them on top of each other. You just had to say the idea here, and then because the idea was set in the middle here, you just had to go through each variable and do that. And now we know that 7y's equals 28, so y is equal to 4. And working backwards from any of those equations, you can see that x is equal to 5. Okay, the next couple are for you to try. You'll have to rearrange this one to get the y's and x's on one side and the answer on the other. So as a first step, this is minus 3x plus y equals negative 2, and x plus y equals negative 6. So the order is important before you make your augmented matrix so that you have x's, y's, and then answers, x's, y's, and then answers. And then you can start. Woohoo! Volume was on. Subscribers, like.